Okay, so we take this, it's useful to be able to do things side by side, right? And we just say, we're just gonna steal all of the inner parts over here, pretty much, right? It should be pretty close to what has been already done. Okay, whatever, I really don't care any messages here. So obviously, first I just changed the name, right? My whole adaptation to the new idea is just and see how it imports the static because of my paste, which is smart of this source editor. So I'm just actually going to get rid of this. I don't need it. I don't need any initial things or anything. In fact, I will also get, so let me resize this, right? I will get rid of this constructor that takes specific initial size. I don't want that either. I just want this to be fully dynamic. And what I want to do is, of course, I want to change this to array list. Array list of doubles. Of course, in Java, you have array list of objects. You cannot use primitive data types, so we switch over to using the double, but it should not be a huge obstacle or limitation on our part. And of course, it no longer needs to be an array. This is a dynamic array of its own. We're going to say new, right? So we can say under any circumstance, let's create an object. So it's going to be array list of doubles like this, and we will use the default constructor. And of course, in our dynamic stack double constructor, which is the same object, we simply no longer need this. We know that every time we begin to work with this object, all we need to do is that we just basically want to initialize the top of the stack to be 0. Okay, then. All right, so switching over to array list, let's do fix imports, which is trivial because it's just going to say Java util import. So this is good. So then, of course, the approach to use array elements to store and retrieve information is not going to work. Instead, we need to switch over to, say, add, right? So add the double. So no longer square brackets, right? So I'm going to say add, I guess I can do it this way. I can just say add double to the list, right? And then the top, I should be able to say, increment top. This will work, I think. Increment top. So it basically should follow the size of my storage. Okay, and then of course when I will be retrieving the value from the stack, what I need to say is some kind of double temporary value equals storage. Let me just get rid of this. This will be returning my temporary value, right? So we're just going to say storage get at whatever the top was, right? And I think if I insert one element, its index will be 0. So top, would that work? We'll see. We can test this, right? So I'm just thinking about what should the index be to refer to a specific element. Perhaps storage get top. Of course, instead of top, I could just use the length of my array, but I think if we add, I need to say -1 because the top will be incremented. Yes, so the top becomes 1 instantly as we increment it. I guess getting rid of the top integer here is not very beneficial because this way we can return, the size full empty. We can continue using this variable, right? But after I say get, I need to remove it, right? So I need to say storage. So now it gets a little longer, so I'll just switch over to the standard format. So I'll just say double temp, retrieve the value, return this temporary value, and now somewhere in between we're going to say storage, remove, add specific index, and that index again will be top -1. Okay, this may not be absolutely most efficient version of what we're trying to do, but this is the demonstration, and we'll just decrement the top and we should be okay, hopefully, right? So we're just switching to array list to manipulate this array list storage, but the benefit is that this storage now is basically no longer limited in size, so which comes with an idea of dynamic stack, right? Okay, so also the length now will be the length, I think now is the method, or actually the size, I think, right? The size of the array list is that, and so full and empty should be equally available in everything. Okay, so then I'm switching back over to my main, and it seems like if I just do this, hopefully, right, dynamic, try to use dynamic, the interface hasn't really changed in any way. The default constructor is still available, clear, push, and everything. Clear, by the way, probably should remove the elements that I need to fix to address the, to remove everything from the storage, to preserve memory consumption, right? So stack double and do this, all right? So switch over to this. Let me save everything, and let's actually, instead of printing the price let's do it the second time to make sure that we properly retrieve it after 2 pushes and 2 pops right here. We should be say price is this and price is that, just to go back to the original 1999 and be able to demonstrate that things got back to normal. By the way, it doesn't hurt to also the tax rate is and display the tax rate for the sake of testing very quickly. Save this, run it. Right, run it, and so here we go. We were able to push it. We were able to change and recompute the price, and then we went back over to the original value. So the thing works, except that again in its implementation, when we say clear, now we also need to take care of the storage. So here top equals 0, and storage needs to be clear, right? Needs to be cleared of any values. All right, so very well. So the things are looking okay, right? So if we really had this demand for dynamic stack, not limited to one specific early decided initial size, this is fine. But then you start benchmarking and testing it with millions of objects and millions of double, and you discover, okay, that this original version, when you work with it, can be more efficient in some situations. In some situations, you know exactly the size of the stack, and you just begin to realize. And by the way, in your benchmarking, in your testing for like performance, right? It's not necessarily that you may be creating that you're really pushing 1 million objects into the 1 million doubles into the stack. It could be that you have a loop with 1 million operations in it, right? And there you discover differences, right? So your stack only grows to like a relatively small size, but then you discover, some differences. So, so then essentially you want to make a decision, right? You want to make a decision. You can say that, you can ask the user for int capacity, right? Capacity. So capacity. Just having trouble with my keyboard here. So capacity is, say, I don't know, 100, right? And you can then say if the capacity is, say, if the capacity is less than, I don't know, some magic number, 999, whatever, right? You want to use the stack of doubles. Or, if this is not true, then you want to use the dynamic stack. Because think about it, down here, nothing had to change at all after we switched over to, from the array-based stack of doubles to dynamic stack of doubles, right? So how do you manage all this? Are you going to use this crazy if statement and copy and paste all of this in two places, or is there a better solution? So, of course, there is a better solution. And let me just point out that right here, what I'll do is that I'll just say iStack, which I typically use for naming my interfaces, iStack stack. Essentially, let me do it this way. iStack, iStack stack equals create stack, okay, and then pass the capacity to this strange method that says create stack. Okay, and then I will add this method create stack. Somewhere it's just another maybe public static method iStack, which returns iStack, which is a bit mysterious right now, but I will clarify what this is, right? iStack create stack, which takes an integer capacity to make a decision what type of stack you want. Of course, the trick with this additional method is that it will contain this if statement, right? It will contain this if statement. And it should be able to do the following. If capacity is low enough, we can say return new stack double, which is based off of the basically based off of the array-based stack object, right? Otherwise, we'll just say we will return instead we will return dynamic stack, because we say, okay, if it's bigger than that, then we're going to say dynamic stack, okay, dynamic stack double. Okay, so how could, and then of course we are not going to do any of this, right? So we're not gonna create those things directly here. Essentially, this type of method, the creator method for stacks, whichever way we want to whichever kind of stack we want to use, we want to decouple a particular type of an object from the actual client, like main, so that it can use either, because the interface, the set of methods is exactly the same. The set of parameters for these methods is exactly the same, and returning values are also exactly the same. It's only this part, the storage part, which is different, and we manage it differently. So very well then. Okay, so how do we do this? We go back to our project, and since we're kind of, technical people here, we say a new Java interface. New Java interface is actually very similar to class. And of course, it will be named iStack. I have this habit of naming my interfaces with uppercase I in front of the name. Notice that what it's going to do is it will create iStack.java, right? So it's very similar to class file, right? But it's going to be this. So finish. And here we go. We're going to, instead of working in our client program, which is main method, we're actually going to stick with the interface named iStack, and it should work for us if we just able to implement create stack and somehow make this interface work for us.